In the closing years of the 19th century, science faced a mystery that would forever change our understanding of matter, an invisible force emanating from certain elements, capable of exposing photographic plates and penetrating solid objects. While most scientists dismissed this phenomenon as a curious oddity, Marie Curie saw what others couldn't: the birth of a new scientific frontier. With characteristic precision, she gave this mysterious force a name derived from the Latin radius, meaning ray, radioactivity, a term that would come to define both her life's work and an entirely new branch of physics. Henri Becquerel's groundbreaking 1896 experiment began as an investigation into whether uranium salts could emit X-ray-like radiation after sunlight exposure, a phenomenon called phosphorescence. He hypothesized that sunlight would charge the uranium, causing it to emit rays that would expose a photographic plate wrapped in black paper. The experiment took an unexpected turn when cloudy weather prevented sun exposure, leading Becquerel to store the uranium and plate in a drawer. To his astonishment, the plate still developed fogging with a clear Maltese Cross shadow, proving uranium emitted penetrating radiation spontaneously, without any light activation. This accidental discovery of Becquerel rays revealed something far more profound than phosphorescence. It demonstrated natural radioactivity, where elements like uranium intrinsically emitted energy from within their atomic structure. While Becquerel had stumbled upon the phenomenon, Marie Curie recognized its profound implications. She observed that uranium's radiation remained constant regardless of temperature, chemical state, or light exposure, behavior that defied known physics and suggested atoms weren't immutable as previously believed. More importantly, she transformed Becquerel's unexpected observation into systematic research, proving radioactivity was an atomic property rather than a chemical one. Curie's breakthrough came while studying pitchblende, a uranium-rich ore from Bohemia. The mineral emitted radiation 4 times more intense than its uranium content could explain. If uranium was the only radioactive element, the ore's radiation should have matched its uranium concentration precisely. Most researchers would have dismissed this as experimental error, but Curie saw the fingerprints of something extraordinary. Armed with an electrometer adopted from her husband Pierre's work on piezoelectricity, Curie embarked on one of science's most demanding treasure hunts. She hypothesized that pitchblende contained traces of unknown elements, far more radioactive than uranium. For 4 backbreaking years in a crude shed that froze in winter and sweltered in summer, the Curies processed nearly 8 tons of pitchblende. They crushed ore by hand, dissolved it in acid, and performed countless chemical separations, all to isolate mere traces of new elements. The payoff was revolutionary. In 1898, they announced 2 groundbreaking discoveries: polonium, radiating 400 times uranium's intensity, and radium, 1,000,000 times more radioactive than uranium, glowing eerily blue in the dark. These findings shattered conventional wisdom by proving radioactivity wasn't unique to uranium, but a widespread atomic property, and demonstrating that atoms could spontaneously emit tremendous energy. As other scientists like Ernest Rutherford and Paul Villard later classified radiation into alpha, beta, and gamma types, they built upon Curie's foundation. Her systematic approach transformed Becquerel's accidental observation into nuclear physics. Marie Curie's battle with radioactivity represents more than scientific achievement. It exemplifies how one researcher's willingness to trust data over dogma can rewrite understanding. In an era when women faced immense barriers in science, her uncompromising pursuit of truth fundamentally changed our view of the universe. From that leaky shed laboratory to 2 Nobel Prizes, Curie's legacy proves that great discoveries often begin when someone dares to ask, "This doesn't make sense. Why?" The birth of nuclear science stands as enduring testament that with sufficient insight and perseverance, even nature's most elusive secrets must eventually surrender. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.